This question wants us to show that this equation has no real roots for p and q elements of real numbers where q is not equals to 0. Let's go step by step. First, we must bring everything to one side so the equation looks like ax squared plus bx plus c. So we need to achieve this, right? Ax squared plus bx plus c. So I'm going to transpose everything to the left. So p squared plus 1 times x squared, and then we're going to transpose the positive 2pqx, then plus q is equals to the 0. So we have moved everything to the left. So our coefficients are a equals to p squared plus 1, b equals to 2pq. You can see, ladies and gentlemen, this is bx, this is ax squared. Then we can see that our c is going to be q, or is q squared. No? Awesome. Then let's go on now. We want to show that this equation has no real roots. Okay? Remember, to have real roots, the discriminant must be greater than or equals to 0. So, which means to have no real roots, the discriminant must be less than 0. So, the question wants us to show that the discriminant is less than 0. Let's show that. Firstly, we write our discriminant, which is b squared minus 4ac. And then we substitute. Let us substitute. Discriminant is equals to, let's make it smaller. Right? So b squared will be 2pq squared minus 4. Our a is p squared plus 1. Our c is q squared. And then we expand our thing. So the discriminant becomes 4p squared q squared. That is this bracket. Right? And then there we're going to have minus. Actually, there, let's do this. No? I'm going to firstly do this. The negative 4, I'm going to multiply it with the q squared. So I have minus 4q squared p squared plus 1. And then, now foiling into the bracket, we have 4p squared q squared minus 4p squared q squared minus 4q squared. I'm sure we all know how to multiply, ladies and gents, at this point. And then we can see that the discriminant is equals to negative 4q squared, because these two guys are like terms and they are going to cancel each other out. And because q can be 0 as per the instruction, and we know that q squared, because a square is always positive, né? So q squared will be positive, which means we are always going to be multiplying a positive number with a negative number. So the answer would be negative. You see? So we are going to say, therefore, the discriminant, this is the discriminant, right? It's always going to be less than 0. And then now, we can see that the discriminant is negative. What does this mean? Therefore, the equation has no real roots. Ne? So therefore, no real roots. Why? Because your discriminant is less than 0. Ladies and gentlemen, remember this. If your discriminant is negative, there is no real party on the x-axis, just complex guessed. Let's keep going and win that maths award.